Okay, here we go. Today we're gonna talk about fuse blowing, and in this situation it could be a little complex. And over the years, it's always been difficult when we're going after intermittent fuses that blow, that we put a fuse in that blow, and it's always tough when we're in that situation because sometimes the customer leaves and he comes back, or they tell him to get a box of fuses from the store and all that. But I want to talk about a methodology that maybe work to our advantage, that would be able to catch those problems easier than just waiting for the fuse to blow. In this situation, I'm using a tail light fuse, and over the years, that has always been the toughest one for me because that goes everywhere. The tail light fuse, when it latches, it goes to the front of the car, it goes to the dashboard, it goes to the center console, it goes to the doors, it goes to the rear of the car, it goes to a myriad of different places. Always the toughest. I can remember back in the day, a guy came into the shop with a Cadillac about 20 years ago, and I didn't have a lot of the technology we have today, a lot of the training, a lot of the equipment, amp clamp, stuff like that. And I tried to fix his blown taillight fuse on a Caddy that, in that circuit, even 20 years ago, a Caddy was, pretty technology rich. That circuit went everywhere. It went to the front, it went over the firewall, back, dashboard, doors, center console, four doors, the trunk, you name it. Anyway, in this method, what I've got here is I've got 5 amp clamps. I know that thinks a little crazy, but the explanation will make more sense as I go. As you look at this schematic, this is from the 04 Honda Accord. There's the scope. If you can see, we got 5 channels running. We don't have current flowing. Basically, we have 5 amp clamps. We have channel A is blue. That is around connector I1 from the underhood relay box, which is not that difficult to obtain. We've all dealt with underhood relay boxes, TIPMs on Chryslers, smart junction boxes on Fords, underhood relay boxes on GM. We lift them, and with service information, we find our connector, and then we peel the tape back, and we find our colored wire, and we get on it. So we have 3 pins coming out of the underhood relay box. We have I1, we have H13 and H14. I1 will come out of the underhood fuse relay box and flow into the under dash fuse box. It goes in at pin D3. It comes out at pin N31. From pin F9, it goes to the rear of the vehicle, across the floor wiring harness to a junction, and then it's going to power the right tail light and the left tail light. Getting back to our underhood relay box, pin H13 and H14 come out of the connector on the underside of the underhood relay box. H14 flows to the right front parking light, and H13 flows to the left front parking light. So this circuit is all over the car. And that's why we've got the 5 clamps here. And I want to explain something about the first 4 channels, A, B, C, D, and are on the respective. You can see them on the illustration. You want to print this out, by the way. Print this out. It will really help you watching the rest of this video. It may be shot in multiple parts, depending on situations. I've got the first 4 channels right here. We are at the underhood relay box. We're hooked into the loops. We have the green channel. Basically, I want to talk about that because I should have talked about that initially. My bad. The green channel is going to what we call our substitute. We have substituted for this fuse 4 because this fuse is intermittently blowing, and it's one of those difficult problems that we want to try. We can make it act up before it actually blows the fuse, where we start to see current intermittently going to ground. So in place of the fuse, I have a 20 amp test light. I know you won't see this on the tool truck. There it is right there. I know the sun is kind of glary, but nonetheless, that is in place right here in the underhood fuse box, in the fuse 4 slot. That 20 amp test light is in place there. The 5th channel, channel E, I want to talk about, because in this method, I'm gonna designate at least 1 channel. I'm gonna call that the reconnaissance lead. That is the purple lead. Right there, you can see it on the scope. It is about maybe 10 or 11 foot of BNC adapter, a BNC to banana adapters, daisy chained to the low amp clamp. which the low amp clamp is inside the vehicle at pin N31. That is fairly easy to get to. That was not that difficult. It was it's a red and black wire on the front side of the under dash fuse relay box. That will move around. That's going to be our reconnaissance clamp. Being this circuit goes everywhere, I got to be able to make that clamp go the length of the vehicle from the right rear of the trunk to the left front of the vehicle. That's about 10 or 11 feet. So basically that's our tethered, we call that reconnaissance clamp, and that is tethered with the greatest length of cable between the low amp clamp and the scope, and it will remain that way during the rest of this demonstration, this video. And what we have here is, you look at the illustration, is you look at the schematic, you study, there are spots, there are green numbers that are circled. There's 7 of them. Those are spots I will create intermittent, very, very, very quick intermittent shorts to ground. Now these shorts may not blow. If you had a fuse been in here, it may not blow the fuse, but we will see action on the scope. So if you look at 1 through 7, we got 1, 2, 3, 4, 5 is there. That's kind of along the floor wiring harness. We got 6 and 7 in the rear of the vehicle. And we're kind of be working backwards because we know the problem, but we're going to see the effect of it on the scope. So if we were in a real troubleshooting situation, we would narrow down the circuit as we watch the current flow in certain areas and stop flowing in other areas. So basically, one more thing, all our lights they don't have their grounds. I left the grounds out, as you can see. Well, they have grounds, but they're not intentional engineered grounds, if you know what I mean. So we're gonna look at them. The tail lights are on right now. Tail lights, parking lights are on. You can see them. And I will get to the scope and we will see, I'll turn them on and off to see what normal looks like and how much current flows normally. Okay, the sun is coming out, which is kind of nice, but anyway, I hope that's we can see that. Okay, you see the scope. I will turn the headlights on and off. Off. And I'll stop the scope. We'll just kind of take a look at what we got. Okay, here we go. Every channel went up when the tail lights went on and off. You can see the difference. So we would almost assume, let's look at our green channel, because that's our amp clamp that will, all the current of the circuit, the entire tail light will flow there. We are flowing about 3.165 amps. Now that's the front parking lights, the rear tail lights, and some inside illumination, the hazard illumination light. That's normal. That's the normal way the circuit works. Should this circuit copper ride to ground, it will flow a lot more than that. So I just want you to know that. We can see that we're high. This is when the lights were off, lights were on. We're high on green, red, blue, and gold, and purple, the 5th channel. That is inside the car. That is the current going to the inward illumination. We call that like dashboard central. That's where the hazard switch is. If you look at your schematic on the hazard switch, you can obviously see that's the illumination for the hazard switch. That's not the power for the hazard switch to turn it on. Anyway, what I'm going to do is I'm going to start the scope, and we're going to take our circuits. We're going to look at our circuit where current is flowing. The parking lights are on. The tail lights are on. The license plate lights are on. The internal illumination is on, and we're flowing current through the circuit. Now I'm going to do one circuit. We're going to go to number 1. Look at your schematic. Look at the number 1 up in about the central upper part of the page. We'll see the left front parking lot. I'm going to bring that ever so slightly to ground. We're going to see I'm going to stop the scope and talk about it and discuss if we were facing a problem like that. What can we infer from the way we're hooked up here? So here we go. Okay. I'll stop the scope and we'll go back and we'll talk about it. Right there is when that spot on your schematic, that's the one spot circled, one number circled in green. As we can see, we're elevated in certain areas and we're down in certain areas. We can say we're high on gold, we're high on green, we're low on blue, we're low on red, and we are low on purple. So let's go back to the schematic and take a look at that. When the relay is latched, we know we got current flowing on green on the third channel through the clamp. That's what turned on the 20 amp test light. We know that we're high on gold or yellow because that is coming out of H13 up to, it's a little bit of a junction. Yeah, take a look at there's a little bit of a loop I put there. That is going to the left front corner. That's where our short is in position 1, and it makes sense now. So now, if we had this situation, if we got the car to act up, if we had this fuse intermittently blowing and we're shaking harnesses or bouncing the car, it doesn't take a long time for that thing to go to ground and cause it short. Now that may not blow, most likely wouldn't blow a fuse. It's too short amount of time for a fuse to blow. You have to get a little more heat. But nonetheless, let's look at the time that thing went to ground just in one spot right here. Let's say that. I'm going to get the milliseconds and we look at that. Okay, that's right there. That's 30 milliseconds. That is like a blink of an eye, or even faster. So we know if we were troubleshooting this car and we got that thing to rise on those two circuits, on the green and the gold, we would be following pin H13. We would be in that circuit narrowing down where our short could be. So we've deducted in closer proximity where the short would be. That is situation number 1. We can see current going down in other areas. One thing I say is a short circuit is like a current hog. It wants all the current, and the other circuits get deprived that don't go to ground. If it's not in the direction of that circuit, as we can see, the burgundy, the channel 5, the blue, and the red all went down. Current stopped flowing through those circuits because the short circuit pretty much hogged all the current. Okay, let's get the scope back. Make sure everything's in a good situation. So that was situation number 1. We can see we will go to situation number 2 and determine where the short would be. So take a look at your schematic, look at position number 2, and we'll see what happens. Okay. I'll stop the scope. Okay, we're high on red and we're high on green, and we can see that. Okay, we definitely take a look at your schematic and take a look where we're not high. We're low on certain areas. We're low on blue, we're low on gold, and we're low on burgundy. It's hard to see because I got that scaled pretty high, because I got to realize in a situation like this, wherever the short circuit is, it's going to draw about 18, 19, 20 amps. So that's why I got the 5th channel scale. But there is a definite, I'll zoom in on that so you can see it. You can see where the burgundy channel went down right there. I just want you to see that. Okay, you see the drop. Okay, so let's get back to normal size. Okay, so let's look at our schematic. The short is in position 2. It is the right front parking light. As we can see, we're high on red and we are high on green because all the current, pretty much green will always be high with a short. That's the clamp that's at the 20 amp test light in the underhood fuse relay box. So we can see we're high on red. So in a situation like this, we can rule out so many other parts of the circuit, and we would follow pin H14 in the underhood relay box, still in the engine compartment, and eventually work that wire, get in and find the short at the right front parking lot. Okay. Okay, let's get back to normal. We're flowing current, the lights are on, and somebody's home. Okay. All right. Okay. All right, take a look at your schematic, and we're going to go to position 3. Take a look at position 3, and look, that's an interesting one. That would be internal to the underhood relay box. So let's look what it looks like when position 3 gets shorted, and what can we determine where current's flowing and where current's not flowing. Okay. Okay. What do we got here? Okay. Okay. Looks like we're looks like there may be a little bit of egg on my face, probably. Okay. Let's look at what's going on. We're at position 3 now. Look at that schematic. What would it look like if right at position 3 if current went to ground? Let me get the scope back on. All right. Okay. All right. Okay. Okay. We're going to ground in position 3. Take a look at your schematic, and I'll explain what happened, what transpired there. We stop the scope. We go to we look at our scope. We're going to analyze that. We're going high on green, but everybody else is going low. We got gold going low. We got red going low. We got blue going low, and we got our little guy amber, our little purple guy number 5 going low. What can you tell from that, looking at your schematic? That circuit's got to be going to ground somewhere before those test points, before the blue clamp, the yellow clamp, the red clamp, and the purple clamp. So we probably deduce that most likely that short would be inside the underhood fuse relay box or very close proximity. It's all about the test point too. Because you got to be, it's from where the clamp is located. It's either before the clamp or after the clamp. In a case situation like this, if you look at those blue, those yellow, and those red clamps, that short is before those, would be before those, where those clamps are placed. So bear that in mind. It's not a slam dunk that it's in the underhood relay box, but it's before the test points of blue, yellow, and red. So anyway, let's get the scope rolling. If the scope should end abruptly, we will come back in a part 2. Just want to give you that heads up. We are rolling, and we're going to look at position 4 now. Look at the hazard switch illumination. That is position 4. That is about central dashboard. You know, when a wire seems to rub on a bracket and something wasn't put back right, and every now and then that copper sort of likes to tickle ground, and if it lays down long enough, it will blow the fuse. So let's see what happens when position 4 is a short to ground. Okay. Stop the scope and analyze. Okay, we can see some action. We know where we're high and where we're not high. We are high on purple, high on blue, and high on green. Low on red and low on yellow. So when we look at the schematic and we're low on yellow and red, we know where the current's not shorted. That's pretty much the engine compartment downstream of our test points. We're high on blue, we're high on purple, we're obviously high on green. Okay, being high on purple's got to tell us something. That clamp is right at the underdash fuse relay box. That short is after that clamp, and so we would follow that wire from N31 up and look at service information, looking at the electrical schematic. We know we're closing in on the area of that short. We know we've narrowed down, we've broken the circuit down to a smaller area. We still would have to work and get service and just keep snipe hunting in on where the wire is shorted to ground. We can see the current flowing in the 3 spots, the green, the blue and the purple and not on yellow and red, and inferring that we sort of narrow down which way the short to ground is. That is position 4. Okay, we will go to position 5 and okay, take a look at your schematic. Remember what I told you about the E-clamp with a purple clamp? I gave that a lot of slack. That's I call that reconnaissance clamp, just a term. They're all doing reconnaissance, but we want to make that one mobile. So anyway, I'm going to end the video now, and we'll be back to look at situation 5, 6, and 7 and the effect of short circuits, and kind of, if we were in a real diagnostic situation, the way to use this methodology to narrow down where our short to ground is. One other thing I want to make note of is, if you look at the schematic, look at the red circles on D3 and F9, and you see question marks there. Now, it wouldn't be surprised that one would question this methodology, that this is overkill, that this is too much, that this is a Rube Goldberg sort of way to do it. If you looked at where those connectors are, they are on the inside of the under dash fuse box. It would take me probably an hour and 10 minutes to get that thing and to pick those wires out. Yes, we would see current flowing through them, maybe or maybe not. Nonetheless, I would never recommend anybody do anything like that. As, I don't know what's the word, maybe you think, as overkilling this is, maybe, you know, or not, you still want to maintain pragmatism. You want to work efficient and smart. So you would tag signals that are obtainable. The purple clamp is at the front part of the under dash fuse relay box, and it was very easy to get to. I just look in service information, you know the colored wire, you know the pin, and I snagged the wire right with my clamp. I didn't have to slack it up or anything. It was right there. The other 3 wires on top, look at the blue, look at the yellow, look at the red. They're fairly easy also. So you want to think about, in this kind of technique, that you still want to maintain pragmatism and not just waste a lot of time trying to get to a wire that would be fairly labor intensive to get to. Anyway, thanks for watching. Best to you, Gary, Shippy, Mr. Ship, all the best to the staff, and I will end this here and come back with a part 2. Thank you. Thanks a lot.